All right, this video is just an additional video for Learning Target 9. Very few notes in the first video, and actually there's more learned by practicing problems together in class. And this was a bell work we did after practicing those problems for 2 days in class, so thought I'd at least record this so you could see how it all kind of fits together. Again, it can't replace being in class and working these together because each problem you learn something different. All right, but in this bell work problem, finding all of the zeros, that's a change in directions, but they're only using the word zeros because we're looking at a function. If we changed f of x to 0 equals x to the 6, blah, 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 then they would be asking for the roots or solutions because that would be appropriate for an equation. So anyways, the directions change, but what we do does not change, okay? First thing is we'll cross our fingers. We know that it's answers. We'll grab the calculator and see if we can find all of the x-intercepts in the calculator, all 6 answers. So to save time, I've already typed that in. It'll turn on for us. So I went into the y equals, typed it in, hit graph, and this is what we're seeing. If you go to the table, you'll see that that's x equals -2. You'll see that that's x equals 4, and that that's x equals 0. Okay, now x equals 0 is a special x-intercept because you'll notice the function is touching x equals 0 and turning back around. So if you remember, that's the visual cue that that's a double root. Okay? So if there's an x equals 0 as one of your answers, the first thing you should think and notice is, well, if there's an x equals 0 solution, there's a GCF in this function. And the GCF of this function is x squared. So our first step is take out the x squared. That will give us x fourth minus x cubed minus 8x squared minus 12x minus 16. And then we'll have to do something else to continue to factor this problem to where it's a manageable x squared, where it's a manageable quadratic that we can solve. So here's what we're going to need to do then. We're going to need to either factor the x to the 4th that we just got, x to the 4th minus x cubed minus 8x squared, blah, 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 or we're going to need to divide by some things. So I want to remind you of a little key concept that we looked at in the first notes. If x equals 4 is an x-intercept, that is the b in this formula. If 4 is an x-intercept, x minus 4, x minus b is a factor. So the fact that this function crossed at x equals 4, that provides us with a factor x minus 4 that we can divide or factor out of the answer that we just got when we factored out the GCF. What that means is this function is divisible by x minus 4. If we look back at the picture, it also crossed at x equals -2. So if x equals -2 is a 0, x plus 2 is a factor. So what that means is not only is our function x to the 4th minus x cubed minus 8x squared, blah, 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 divisible by x minus 4, it's also divisible by x plus 2. So we do have a choice here. We can either divide by x minus 4 or we can divide by x plus 2. I also wanted to show you this visually as a factor tree so it might make a little more sense. Okay, so let me explain here what we're looking at. We're looking at the same information that we were just discussing. We saw x equals 0 as a double root. We saw x equals -2 and x equals 4 as zeros from the graph. Now the factors for x equals 0 and x equals 0, the factors become x times x or x squared. So as we did earlier, that's going to be the first thing in the factor tree that we factor out or divide out. We chose to factor that out, and we got a 34 polynomial. Now we had to have the decision of either dividing by x plus 2 or x minus 4. So obviously you can see here I chose to take the x plus 2 factor and divide by x plus 2 in this tree. Taking an x to the 4th, a degree 4, and dividing it by an x to the 1 is going to give us a degree 3 answer. And then we'll be able to take that answer in this factor tree and factor out or divide x minus 4, the final factor we found from the calculator. And when we do that division, a degree 3 divided by a degree 1, we'll end up with a degree 2, which is a quadratic. And we'll be able to solve this problem no matter what quadratic we get, because we could at least use the quadratic formula. All right, so that's kind of the concept. You might need to pause this and look over it and, maybe rewind and hear that, because I kind of discussed it pretty quickly. But we are going to divide by the factors we found from the calculator. All right, so back to the previous slide. We're going to just follow the script that we just discussed. So that script said we're going to factor out x squared first. Check, we did that. Then we're going to divide by x plus 2 and get some answer. I don't know what we're going to get, but it's going to be x to the third. The degree will be 3. Then we're going to take this function and divide it by x minus 4. So we will take our answer and divide it by x minus some answer, which will be a quadratic of some sort. You have a choice to either use long division or synthetic. So I will choose to use synthetic. So scratch work will go over here. First, we are dividing this function, this polynomial, we're dividing it by x plus 2. That would put a negative 2 in the half box, and the coefficients 1, negative 1, negative 8, negative 12, negative 16. Remainder bar, this is addition, and then we'll perform that division. Bring down the 1. Negative 2 times 1 is negative 2. Add those and we get negative 3. Negative 2 times negative 3 will be 6. Add those, we get negative 2. Negative 2 times negative 2 is 4. Add those, we get negative 8. And then finally, negative 2 times negative 8 is 16. Add them, remainder of 0, which better be what we're dividing by a factor. So now we know this is x cubed minus 3x squared minus 2x minus 8. So now we're going to take that answer and divide it by x minus 4. You have a choice. If you like factor by grouping, you could take that polynomial and factor out x minus 4 by grouping as well. Since I'm in the division mode, I'm just going to go over here to the side and do another division. So we are dividing this time x cubed minus 3x squared minus 2x minus 8. We're dividing that by the other factor, x minus 4. So in the half box will be a 4, and the coefficients will be 1, negative 3, negative 2, negative 8. All right, bring down the 1. That's again an addition bar. 1 times 4 gives us 4. Add those, we get 1. 4 times 1 is 4. Add those, we get 2. 2 times 4 is 8. Add those, we get a remainder of 0. And that 1, 1, 2 represents the quadratic. 1, 1, 2 represents the quadratic x squared plus x plus 2. All right, so now using kind of the zero product property, finding all of the zeros, we're kind of visualizing that as 0. When would x squared equal 0? Well, when x is 0, and that's a double root. We already saw that in the calculator. We already knew that. That's a double 0. When would x plus 2 equal 0? Subtract 2, negative 2. Again, it's a single root, but we already knew that from the calculator. X minus 4, when would that equal 0? Add your 4, when x is 4, another single root. So we've got 2, 3, 4 of the 6 roots. Our final 2 roots, our final 2 zeros, and you'll notice I use the wrong word every now and then when I'm discussing because they're so similar. The zeros are what we're finding. The other 2 zeros are when that quadratic equals 0, and we're forced to use the quadratic formula. Opposite of b, plus or minus some square root over 2 times a, and the discriminant would be b squared minus 4c, so 1 minus 4 times 2, that'd be negative 7. And the only thing you can do to reduce that square root is poke the eye out. The negative under the square root, that's an imaginary for this degree 6 polynomial. So to finish this off, the zeros were as follows. X equals 0, that counts twice. Then negative 2 counts once. Then 4, so that's 4 answers. And then negative 1 plus or minus I squared to 7 divided by 2 counts as 2 imaginary answers. So we have 4 real rational roots. They're all rational. This one, this one, this one. They're all rational. and then 2 complex roots, the 2 imaginary answers we found with the quadratic formula. So again, this doesn't cover all of learning target 9 either. This problem doesn't, but it shows another glimpse of how division and factoring all work together to find the 6 zeros you're needing to find. Coming to tutoring and working the homework together is just the best way to practice these because each problem is different and you learn something from each problem that we do together. So, but that's the learning target 9, another good problem.